In this video, we will discuss problems based on Venn diagrams involving higher number of variables. Generally, we are accustomed to solving Venn diagram problems involving 2 or 3 variables, and generally we represent them by 3 symmetric circles. In case of 3 variable Venn diagram problem, let's say these 3 represent A, B, C variables, and this is a point of intersection of all the 3 variables, and then other regions represent other intersections and unions of these 3 variables. So understand that whenever the number of variable n is a prime number, then Venn diagram is symmetric. Okay, so this is symmetric. You can understand this to be something like a 120-degree symmetry arrangement, and even in case of n is equal to 2, you can see a 180-degree sort of a symmetry in these 2 circles. So for n prime, there will be a symmetric arrangement. However, if n, let's say for example n is equal to 4, the symmetry will be lost. There will be no symmetry in the look and feel of Venn diagram. And then when n is equal to 5, the symmetry returns. And for n is equal to 7, 11, and so on and so forth, the symmetry is sustained. However, the complexity of the Venn diagram goes on increasing, and this the number of zones and regions go on increasing, and there are a lot of permutations involved. So let's not go into that, because that's not going to solve our purpose and not going to simplify things for us. So let's now take a common approach to solving problems based on any number of variables, be it n is equal to 2, 3, 4, 5, 6, 7, or whatever. So we'll take up a problem involving 4 variables to start with, and then we'll build up on the concept here. So let's say there's a class of 150 students, right? And there are 4 subjects: physics, maths, chemistry, and English. Let's say all these 150 students appear for exam involving all those 4 subjects, and the number of students passing in physics is 135, number of students passing in maths is 125, number of students passing chemistry is 110, and number of passing English is 100. So let's say that's the case. Then we need to find the total number of, minimum number of students who are able to pass all the 4 exams. So minimum number of students who pass all the 4 exams. This is a relatively easier version or variety of question. So how am I going to do that? Now let's follow this convention. Let me draw an XY plane. This is my y-axis. This is my x-axis. This is my y-axis. First of all, the total number of students is 150. So I will draw a line whose equation is x is equal to 150, and this is my line with the equation x is equal to 150. I have 4 variables here representing a number of students passing in respective subjects. So let me represent the first variable. Let's say I start with physics, and P denotes the same, and let's consider y is equal to P line, and on that I will take a line segment of length 135. I can take a full line segment of 135 or break it into chunks such that the sum of all the chunks adds up to 135. In this case, let's take the entire chunk together. Let's say it's 135 here. Now I'm trying to plot the variable m corresponding to maths, represent it as 125 length. Now see, I'm trying to minimize the number of students. So in that case, what I need to do is I need to minimize the overlap happening between or across the variables or across the lengths that I'm drawing here. In order to minimize the number of students passing the exams, I need to minimize the overlap. So there are two parts regions over here. One is 0 to 135, which has one line already on the line y is equal to p, and from 135 to 50 there is no line. So it will be prudent if I start populating, think it like consuming some part of 125. So let's start consuming in this range. This is of length 15, so 15 out of 125, let's say, has been consumed in this region. I am left with 110. Now I can choose any part of 0 to 135 and put the entire 110 in that part, and it will not be a problem. So if I choose it from 0 to 110, or let's say 10 to 120, it is immaterial. So let me choose it from here on. Let's say I choose 110 here. This is of length 110, this is of length 15, so this is entirely consumed now, 125, and this point becomes x is equal to 25. Now I'm trying to populate C corresponding to chemistry. Now again, if you see, this region has one line in total till now, this line, then this range from 25 to 135 has two lines, and this range has one line only. So it will be good if we start populating from those areas or those regions where only one line is present. So let's say I'm trying to consume some part of this 110, so 25 of it will be consumed here, right? 15 of it will be consumed here. I am left with 40 is gone out of 110, so 70 is left. Now I can put 70 anywhere in this portion, right, of length 110. I can put anywhere. I can put 25 to 95 or 30 to 100 or any place. So let's say I start from 25 itself and go till 95. Okay, this is 70 in length, right? Yeah, and this is the point 135. Now English, I'm left with English. Now there are two lines in this region, there are three lines in this region, two lines in this region, and two lines in this region. So there are three regions of length which are having two lines each, and one region where one range where there are three lines. So let's start with the two line ranges. So out of 100, my 25 will be consumed here, 40 will be consumed here, and 15 will be consumed here. So essentially 40 has been consumed here, 15 here, and 25 here. So what all am I left with? Total consumption is 15 plus 25, 40 plus 40, 80. I am left with 20. All I need to do is consume this 20 over any part of this length of 70. So it could be anywhere from 25 to 45 or from 35 to 55. It is immaterial. So let me start from here only, 25 to 45. Okay, this is total consumption, and this is, if you sum 25, 20, 45, 40, 85, 50, 100, so entire 100 has been consumed. Now this is the leftover area. Now in doing all this, I have already accounted for the fact that I am considering minimum number of students, because I have already taken into consideration that the overlap that is happening is minimum possible. So all that I need to do now is check for regions or range in which there is an overlap of 4 lines, because I was interested in knowing the minimum number of students who have passed all the 4 subjects. So this is a range of 3 lines, so this is out of consideration. This is a line of 3 this is a range of 3 lines out of consideration. This is a range of 3 lines. So the only line of range of 4 lines is this particular area, and I have to check for the limiting value in this particular area. So this is 20, this is a bigger line, this is a bigger line, this is a bigger line. So the only part that is the limiting value is 20 is common, so my answer will be 20. So if I represent it as minimum of 4 subjects, minimum number of students passing all the 4 subjects, this is nothing but 20, right? You hope you got the concept what I'm trying to do. I'm trying to minimize the overlap area, and then finally trying to see which part is common to, which a region or range of values of x I have 4 lines. So now another way of looking the same question would be, let's say this is a, after consumption of 135 the leftover value is a, after the consumption of this entire 125 the leftover part is b, after the consumption of this part 110 this is the leftover part which is c, and after the consumption of 100 this is the leftover part which is d. Let's assume that to be. So if you see what is the projection of a on the x-axis, this is a itself here. What is the projection of b on the x-axis? This is b here. What's the projection of c on the x-axis? It is c here. And what's the projection of d? It's d here. And this is 20, and this is what we had to find, right? Minimum value that came out as 40. So let's say this is k. Let's say this is k. Its projection is k. So if you sum all these, if these all have been consumed, I am trying to say that entire 150 has been consumed. So k is nothing but 150 minus a plus b plus c plus d. That's right? So basically what I am doing is I have taken out 135 from 150 and I have considered the projection of that. So what is 150 minus 135? It's basically 15, the leftover. What's the leftover here? 150 minus 125? It's 25. What's the leftover here? 110 has to be reduced from 150. This is 40. And what's the leftover here? It's d is 50. So basically it's 150 minus sum of all these, which comes out to be is 40, 40, 80 plus 50, 130. 150 minus 130 is 20. And this happens to be the same as we found out earlier, right? Now what I am doing is I'm just subtracting each of the individual values from the total value. So if I subtract 135 from 150, I get 15. This gives me 25. If I subtract this from 150, this if I subtract from 150, I'm getting 40, and this I'm subtracting with from 150, I'm getting 50. Now just add these up. This would be 130, and now this should be subtracted from the 150. So this is what we are doing here. Basically when we are making gaps like these, we are leaving unconsumed parts. We are basically, and then we are looking at projecting them on the x-axis and seeing what's the sum of all this. There is nothing but 150 minus the actual intended value of minimum number of students passing 4 exams. So hope you get the concept here. Now, assuming that this is clear now, let's move on to another level of problem involving 5 variables and other type of questions in those 5 variables. So let me make some space. Now, since you have some clarity now on what we are dealing with, let's say there is a class, similar type of a theme. There could be different themes, like probably players playing different type of games like hockey, cricket, or something of that sort. Let's keep the theme, stick to the same theme as of now, because that would be easy to relate to now since we have already done a question on that. So let's take a class of 100 students and let there now be 5 subjects: P for physics, M for maths, C for chemistry, E for English, H for history. Let's say in an exam involving all these 5 papers, 95 students pass physics, 90 pass maths, 80 passed chemistry, 60 pass English and let's say 10 pass history. Okay, now let's try to find out maximum number of students who pass any 4 subjects. Maximum number of students. Now clearly this is an n is equal to 5 variable problem where there are 5 variables involved. Now what I'm trying to do is maximize for 4 variables. So my problem statement is maximum number of students who pass 4 subjects. So how am I gonna do that? Let's start with the same way of solving the problem. Let us make an xy plane. This is my y-axis. This is my x-axis. Let me draw it bigger so that there is more clarity. Now first step is total number of students is 100, so let me draw a line x is equal to 100. This is parallel to the y-axis, right? This is my x is equal to 100 line. Now I'm looking at plotting P. Now I have to find maximum number of students who pass all the 4 exams. So when I say I'm looking at finding maximum number of students, what I should look at doing is try to maximize the overlap area. Earlier in the question we discussed, we looked at minimizing the overlap area. Here we will look at maximizing the overlap area, and that would at the end ensure that I have taken care of the fact that I am looking only for maximum number of students. So let's start with the first one. I have to consume 95 in all. So let's draw a line representing 95. This length, this is x is equal to 95 and this length is 95. Now m is equal to 90. So I am now looking at populating m is equal to 90. So there are 2 regions again, 0 to 95 and 95 to 100. This has no line and this has 1 line. So in order to maximize the overlap, I'll have to take 90 of m just below this region wherein there is already a line present, and I can take it anywhere in this, like from 0 to 90 or from 1 to 91 or from 5 to 95, anywhere in this range. So let's say I start from here only and then go up to 90. Okay, now let's talk about chemistry. Again, in order to maximize the overlap, there are 3 regions now, with one with 0 lines, the one with 1 line, another with 2 lines. So we'll obviously look at 2 lines first because this has this will ensure maximum overlap. So let me draw a line of length 80 from here to here. I can draw this in the entire 90 length, from probably 10 to 90, 9 to 89, or even 0 to 80. So let me draw this case. This is 0 to 80. So I'm still ensuring that there is maximum overlap. Now look at populating English. Now I have to populate 60. Similarly, this area has maximum lines, so I'll populate 60, something like this. This is my 60. Now my question was for passing 4 subjects, right? Maximum number of students passing 4 subjects. Till now I have 60 as the maximum value. Now I am left with one more subject which I need to populate. So where do I put this? Should I put this here, this 10 here? Should I? What will that do? I've already made 60. If I put a 10 here, it will eat into this share of 60. So if I put a 10 here, this first 0 to 10x will consume 5 lines, which will make our case weaker, and then this 60 will be reduced to 50 because there will be only 4 line only 50 units length left in 4 lines, covered in 4 lines. So let's not do that. We cannot put a 10 over here. Now the trick is that we must try to increase the value of 60. We already know that we have 60 in hand, right? 60 is there, but we can also, if we now should look at increasing the value from 60. What if I see this region clearly has from 60 to 80? If you see, there are 3 lines already present. So if I place a 10 between 60 to 80, I will have 4 lines again. So I would have 4 lines here as well as I will have 4 lines here. So in all, I'll add them up for 4 lines. So that's all I'm looking at. So at any place from 60 to 80, I can place the left 10. It could be from 60 to 70, it could be from 65 to 75, it could be from 70 to 80. So let's put it from 60 to 70. This is x equal to 70, this is x equal to 60, this is 10, and this is what? This is 60. So number of lines, just see the region, the values of x, range of x, in which there are 4 lines. This is the first range, which gives me 60, and this is another range. There are 1, 2, 3, and 4 lines. So this is 10. This is a limiting value in this. 10 is the shortest value in this. So this is 10, and there are only 2 lines here, and there is 1 line here and 0 line here. So these are out of contention. So my answer will be 60 plus 10, 70. Right? Let's say that this is maximum number of students who pass four papers. So you understand here that I was looking to maximize the overlap area in order to ensure that, see, this is automatically taken care of. Once I'm trying to maximize the overlap area, I'm already thinking of on the lines of maximizing the number of students passing those 4 exams. Or so just the trick here included the smallest number that we had was to be placed in such a way that, you know, my original figure is not disturbed. Till this step I had a 60, and if I had put a 10 in this region, it would have eaten into the 60 and reduced it to 50. However, actually I'm doing the reverse. I'm trying to increase 60 by putting 10 in a region which already had 3 lines. So putting a 10 here would mean I have 4 lines now with the length with a common part of length as 10, and here a common part of length was 60. So 60 plus 10 gives me 70. So this is the maximum possible case in such that maximum number of students pass 4 papers. Now let's say I'm looking at minimizing this and 4 variables, and I'm looking at finding the minimum number of students who pass 4 exams, 4 subjects. So how about that? So what we do in that is, let me get rid of this. Let's say I have the same data set, and I am looking at minimizing, you know, the number of students passing 4 exams out of these 5. So let me draw my xy plane again. This is my x-axis, this is my y-axis, this is my x is equal to 100 line, this is my x is equal to 100. Now in order to minimize, I must make the overlapping area, I must look at minimizing the overlapping part among different, you know, variables. So let's say I'm trying to consume 95 length of p. So let's say I have 195 here, x is equal to 95. Now when I'm drawing for m, I'm drawing 90. I must take this part into consideration first, because this has 0 lines and this has 1 line. So first 5 I will consume here, this is 5, and rest 85 I can consume on any part of this 95. So let's say we consume 85 here, this is 85, and this is 590. Okay, now while populating C, similar consideration has to be made. There are 2 lines here, there is 1 line here, and there is 1 line here. So what I can do is, in these 2 lines I can look at, beneath these 2 lines I can look at consuming 80 first. So 5 is consumed here, then this is 10, so 10 is consumed here. I'm left with 80 minus 15 is 65, so I can choose 65 length 65 at any part of this 85. So let me choose the 65 here directly. So this is my entire consumption of 80. Now look at consuming 60 of English. There are 3 lines here, so let's not do that. Do this part. 2 lines here, 2 lines here, and 2 lines here. So first we'll populate 60 in these areas where there are 2 lines. So 5 will be consumed here, 10 will be consumed here, and this is what length? 20. So 20 will be consumed here. So in all till now we have consumed 35. If we take 35 from 60, I'm left with 25. So I can, still consume 25 more in this range from 0 to 65. So let's say that I've consumed in this part 0 to 25. So this is my entire 60 consumed. Now the last part, H is for H. I have a 10. I have 4 lines here, I have 3 lines here, I have 3 lines here, I have 3 lines here, and I have 3 lines here. So I can put this 10 perhaps in any part now, because it is immaterial. Because thing is that I was looking at minimizing 4. I'm looking at minimizing 4 variables. So this already has 4 variables. If I put a 10 here, this makes it 5 variable, right? So I will be reducing the case here. If I introduce a 10 here, it will be actually like increasing the overlap part of 4 variables. So let's not do that. Same is the case here, same is the case here, and same is the case here. So if I were to introduce a 10 in either of the areas where there are 3 overlaps already, it will make 4 lines in that region, and if 4 lines are made, it will only add to the number of students passing 4 exams. So let's not do that, because we are looking at minimizing. So in this case, in this particular case, what we'll do is we will put a 10 here, let's say. So this will do what? This will take this as 5 lines. So I'm left with how many parts are now common for 4 lines. I have already taken into consideration the fact that I was trying to minimize the overlap area. So all I need to do is check for the region or the range of values of x in which there are exactly 4 lines. So if I see here from x equal to 0 to 10, there are 5 lines. From x is equal to 10 to x is equal to 25, which is 15 in length. There are 4 lines. This is our zone of consideration. There are 3 lines again, there are 3 lines again, and then there are, in all the regions there are 3 lines. This is the only part that is of interest to us. So my answer is 15. So minimum number of students passing 4 exams is 15. So this is pretty neatly understood. The key part here was, in addition to minimizing the overlap areas, the last value, the smallest value, had to be chosen in such a way that it does not increase the overlapping of, increase the variable, the 4 variable together. So what I did is I choose that line such that it consumes or eats away some part of this 25, and this 10 actually ate up 10 units of this 25, and I was left with 15, and this is the answer.